Yeah, can everyone see my screen right now? Okay. Yeah. Okay. We'll be just getting started. So, hi everyone. Welcome to today's session on iMaster NCE-IP data recovery disaster recovery solution basics. So we'll be focusing on the iMaster NCE-IP as our example for today, but actually disaster recovery can also be applied for campus, fabric, and other domains. But we'll be just focusing on the NCE-IP case right now. So here's an overview of today's contents. Don't be scared of all these like technical terms and the 6 chapters. Disaster recovery is actually very structural and easy to understand. So let's get started. So for here, let's introduce some background. Like, why do we need a disaster recovery system? Let me have my pencil out. So actually, when we're using like one site, let's say we only have one site here. Within this one site, we usually have some like backup mechanisms built in. So for normal cases that are not like considered as disaster, we have backups for hardwares. Let's say here we have backup for the NIC bound, we have backup for disk, and we have backup powers and backup fan. We have everything backup. And for virtualization platform, there's also like a backup method like within one site. And for database, there is also the same case. And for application, for the application layer, we also have backups. But like, why do we need like a disaster recovery system? It's like for normal backups, when one thing is done, the other thing is gonna like backup you, right? The other thing is gonna come into use. But what if there's like a fire and an earthquake and your entire site is down? So now you need to switch to another site. You need to switch to another site. This is why we need a disaster recovery. So yeah. So for natural disasters and like key exceptions, we need a disaster recovery system. The disaster recovery system consists of 2 sets of NCE. The 2 sets of NCE are deployed at 2 remote sites. So when DR system is running properly, data of the sites that provides services is synchronized to the peer site in real time to ensure the data consistency between when a fault occurs at the site that mainly provides the services, you can manually or automatically switch to the other site. You can just switch to the other site when this entire site is down, and to ensure your service can keep running without problem. So for the manual switching is easy, but for automatic switching we have two different ways to control it. Either is completely on its own, or there's a third-party site to provide arbitration. So in this way we can ensure the service continuity and reduces the loss caused by the disaster incidents. So before we dive, the last page introduces you like why do we need 2 sites? And before we dive into the entire disaster recovery solution, let's make sure we are on the same page for some basic concepts. So on this page, we're not going to go through everything, and let's just focus on things that are important. These are the important concepts that we're gonna go through together. And so these are the 5 sites. 1, 2, the sites 1, site 2, site 3, and these 2 sites. So we focus on the sites and we focus on links. So basically, the disaster recovery system is 2 sites or 3 sites and links between them. So let's go through this first. The primary site is a physical site. Actually, the first 3 sites are physical sites. So the physical side means the primary side is determined during the installation and will not change with the active or standby switchover. The primary side product is active and provides services at the most time. So the secondary side is also a physical site. So the secondary side is determined during the installation and will not change with the active standby switchover. So if this is called primary and this is called secondary, then they're like physical sites. That's always called by this name. And the third party side is when the switchover is gonna happen. It's gonna provide the arbitration between the two sides. And how do we determine which side is currently in use? That's the logical term, active site and standby site. So the active site is whichever site that's currently providing services, and the standby site is whichever site that's providing the protection for the active site. And so if you still remember the thing, the image from last page, we have one site, and this site is always the primary site. Let's call it site 1. And we have another one here for it's always called secondary. So secondary, and this is physical. And then we have a logical term. So if this one is in use, it's called active site, and this one is providing protection for it. It's called standby or like backup site. And if this one's down and this one's in use, now we logically call it active site. Now this one is active site, but it's still the secondary site. So you see the logical term and the physical term. And if we have a third party site, then it's also a physical site. You need to physically have a site in order to activate this service. Okay, so these are the sites that we have, and then we have 3 kind of links. So the most important one is a heartbeat link. It's like heartbeat. Is the heartbeat link. The primary and secondary side communicate with each other through the heartbeat links to detect the status of their peer sites. So the data recovery, so the disaster recovery system checks the heartbeat links for every 10 seconds. If the 2 consecutive checks have the same results, then the disaster recovery system updates the heartbeat link status to the web client. And so this is like a heartbeat, and they're trying to detect like whether their peer is currently okay. And the other one, so this one is to check the condition for their peers. And the second one is data replication link. For data replication link, it's basically like the name said, it replicates data. So the data is synchronized from the active sites to the standby sites through the data replication link. The DR system checks the data replication link every 30 seconds and updates its status to the web client. So when this one is working and this one is not working, they're constantly replicating data from the active one to the standby one. So as soon as the disaster happens and the switchover needs to happen, the data are all synchronized. And the third link, so now we have 1 link, 2 link, and the third link is arbitration node communication link. So the arbitration service periodically checks the connectivity between the primary, secondary, and third party sites and shares the check result through the arbitration node communication link. The arbitration node communication link exists only in the a DR solution with third-party arbitration. So if we introduce a third-party site, which is let's say 3 here, and this one automatically brings with it the arbitration communication link here as a triangle. and we will be constantly seeing this image later in the session. Yeah, so hopefully you guys have a better image for the DR solution, for the NCE DR solution. And this is the difference between the active and the standby side. So you can see this image is a prettier one than the one I just drew in the last slide. So here's the primary side, the secondary side, and the heartbeat links. Both of them are tracking each other through the heartbeat links, and data replication links replicates the primary side data to the secondary side. Yeah, and if we have a third one, then there's a arbitration link. So the difference between the active side and the standby side is that is shown here. Let's see. Yeah, basically is for the management plane, for the active side is running, and you can log into the management plane of the active side. And for the standby side, the management plane also needs to be running because it's the management plane, and you can log in to the management plane of the active of the site. And the operations and management plane, the active side obviously is working, but for the standby side, you cannot log into the O&M plane of the standby site. And for service status, all the service of the product are running at the active site, and at the standby side, only the DR related basic services of the product are running. So this one basically is just there for backup. And for data instance status, the database instance of the product at the active side are in master or slave state. And the database instance of the product at the standby side are in dual slave state. Yeah, so this one is master and slave. This one is dual slave. And for the DR operations, you can perform switch to standby operations for the product at the active side, but cannot perform takeover operations. And in contract, you can perform takeover operations for the product at the standby side, but cannot provide switch to standby operations. And for alarming reporting, the alarms of the active sites are reported to the operations and management plane of the active site. And this one's also the case. The alarms of the standby site are reported to the O&M plane of the active site. Yeah, so after we have go through the introduction and common concepts, let's get into the technical principles. And yeah, so basically for like technical, like kind of like technical terms, it just means like which node connects to like which link, and how everything is achieved in the DR system. So the DR system of NCE uses the Huawei developed DR services, and customers do not need to purchase the third-party DR software. So for U2000, you need to purchase a third-party software, but right now everything for NCE, for iMaster NCE, everything is Huawei developed. Yeah, Huawei developed right here. We're highlighting it. And now let's focus on the right-hand side. Let's focusing on the right-hand side to look deeper. So the primary and secondary sites use the heartbeat links to check whether the peer site is normal in real time. And the heartbeat links are established between the management nodes at the primary and secondary sites. So we see here, the heartbeat links, it only connects to the management node, the OMP node for the both sides. And here you see DR manager and DR manager. for both sides. And remember, the next link is the data synchronization link. The data synchronization is implemented between the primary and secondary side products in real time through data replication links to ensure data consistency between the two sides. The replication involves multiple nodes at the primary and secondary sides. So we see here, in order to replicate our data, we need to replicate common service to common service, and OMP to OMP, and our DB database to database. So for data replication link, there's multiple nodes that we need to connect. Yeah, connect to the secondary side. And the heartbeat IP, the heartbeat IP address and the data replication IP address must be on the same network plane. Heartbeat links and data replication links can reuse the internal communication network or northbound network, or use an independent network. So we'll be showing you everything about the network plane later in the slides. So I'm not gonna get deeper into it, but like if you want to see, I can show you like right here. Yeah. So for here, this is what the network means. So different nodes needs to be connect to different network plane so that to ensure the DR system's working. So let's get back to our slide. To where we are. Yeah, this one, the biggest takeaway is how the two links connect to nodes, and also right now for NCE, it uses Huawei developed services for DR system, for DR solution. And this one, like, don't be daunted by like all these information on the page. We're just gonna be focusing on the central part, and so this one is the same thing. It emphasized the Huawei developed for right now, for here, and also for the third party side arbitration. We support manager, controller, and analyzer scenario. This one, if you look closer, the only difference between this one and the last page is here. We introduce a third party site. Later we'll be telling you why do we need the third party site. So along with the third party site, we have arbitration side communication link. So basically, one site, one triangle link. So for the triangle link, each of the side is constantly monitoring the other two sides. So the third party side is monitoring the primary and secondary. The primary side is monitoring the heartbeat, the arbitration heartbeat for the third party side and secondary side. And secondary side is monitoring the arbitration heartbeat for primary side and third party side. Yeah, so they're monitoring everything other than themselves. So the arbitration node at the primary and secondary side establish an arbitration side communication link respectively with the third party side. The arbitration side communication link can reuse the internode communication network or northbound network, or use an independent network. Multiple arbitration service can be co-deployed at a third-party site. So one iMaster NCE DR system corresponds to one arbitration service and at the third-party site. If multiple NCE DR system exists on the live network, multiple arbitration services can be deployed at the same third-party site to reduce costs. A maximum of 10 arbitration services can be co-deployed at the third-party site, and the arbitration services of multiple software versions can be co-deployed. If a third-party site is faulty all arbitration services at the third-party side cannot run properly. So in this case, you need to reinstall all the arbitration services. Yeah, so multiple arbitration services can be installed at the third-party side. So here on the left side, we can see that we need to deploy using a third-party software Veritas in the U2000 era, and now we use Huawei developed system for NCE. This is a comparison between U2000 Veritas and NCE DR system. Let's see what we need to focus on here. Yeah, so U2000 HA service use Veritas, and for iMaster NCE, the NCE DR solution uses Huawei developed software, including a DR manager. DR manager, remember, is in the OMP node, and the service is installed with NCE at each site in the DR system. And to compare the principles, let's focus on the new one that we're currently use for NCE DR. For DR management, NCE DR service manage the DR system, create DR relationships, perform the switchover, and monitor resources. And for the active and standby arbitration, if the heartbeat between the primary and secondary side is abnormal, the arbitration service determines the active site and notifies the DR service to perform the active standby switchover. And the data synchronization for iMaster NCE, the NCE data is classified into the database data and non-database data. We'll be seeing the database data and non-database data later in the slides. And database data is synchronized through the data synchronization function provided by the GaussDB, our GaussDB. And non-database data is synchronized to the secondary side in real time through HFS or MQ service of iMaster NCE. So the function comparison for U2000 versus NCE, let's see. So basically NCE can do all what Veritas can do, and this is the main takeaway for this slide, I guess. And NCE introduced boosts in some crucial functions. So for monitored resource, resource, the this is the biggest highlights for the page, I guess. So let's focus on here. Key NCDR can do key microservice, network port fault on the server, and database instance fault. So so you may ask, what does the monitor microservice mean? To be concise, this is all about like trigger the site switchover. So let me be more specific. So we want to switch, not like we want to switch sides. If there's a problem, we definitely want the good side, the okay side to take over, right? To take over, to like to ensure that the disaster does not cause a lot of problems. So so in the past, the entire site needs to be down in order to trigger the switch to the secondary site. But like right now, what iMaster NCE can do, the NCE DR system provides a smaller range way to trigger the switchover. So if the crucial function, like microservice crucial function, is down and the entire thing is not down, it can also trigger the switchover, so that the crucial function that is down is can be instantly switched to the standby side and get into use. Yeah, and next we'll be get into the data synchronization and system monitoring. So on the right hand side, um, let's see the left hand side first. This is what we say say on the last page. For the database data, we use GaussDB to synchronize the data. And for non-database data, we use MQ or HFS to synchronize the data. And on the right-hand side, now we have a more complicated detailed image for the DR system. We can see that on the multiple data type, there are multiple data type for GaussDB and for MQ, HOFS. They all go through the replication link right here. Yeah, and there's also one thing to note is that the performance data of NCE analyzer stored in the read database cannot be synchronized in real time. To ensure that the performance data at the primary and secondary side is consistent, you need to back up the performance data at the primary side to a remote SFTP server and restore it from the remote SFTP server to the secondary side. So some database cannot be synchronized at real time, and you need to manually do it. So if you're actually like doing this, make sure you keep an eye on here. And next one is DR switchover. What are the ways that we provide you to switch over the sites? So basically, we have manual switchover, and automatic switchover, and then automatic switchover with third-party side arbitration. So this is actually the journey of evolution of our DR system evolution. So at the very beginning, we can only do manual switchover. We need 2 equipment rooms. The 2 equipment rooms as we drew, one is primary, one is secondary, one active, one standby, and the heartbeat links and the data replication link. And we have 2 sites. And this is triggered by the engineer that manually do the switchover. So the application scope is NCE manager, controller, analyzer scenarios, and NCE manager scenario. So so you may think like, what if we can have a better solution for the switchover? Now we have the automatic switchover. For here, you still only need 2 sites. You only need 2 equipment room, and the status of the primary and secondary side need to be monitored in the real time. So after one side is down, it automatically switch to the other side, like lowering the risk of human like reacting. But it may create a problem. What if this one is not down and this one is up? So then we're gonna have 2 active sites. So the problem for 2 active sites is that like probably a lot of you here are experts of it. Like when you are doing the services, you're deploying service for 2 times. You're deploying service, you don't know like which one is deploying the service, or like both of them are deploying the service. So it's gonna create so double active and dual active is gonna create huge problems. Like without human controlling, the automatically switch over can be faster and more can be faster, but it creates a dual active site problem. So how do we solve this? we introduce a third-party side that that provides arbitration for switchover. So, but for the third-party side, you need another equipment room. So the only like, so for a good solution, there's kind of a small downside for it, is that your cost might increase because you need a new site. I guess this is the only downside. There's three equipment room, and status of the primary and secondary sites needs to be monitored in real time. After the site level fault occurs, an active standby switchover needs to be quickly implemented to restore the service. This mode prevents dual active sites from happening when the network between the two sites is abnormal, because if this one, so if this one is not down, it's gonna this one is gonna know that the third party side is gonna know, and this one is not gonna go up. If this one actually goes up, and this one will tell the site to go down to the standby. And let's see the application scope for the application scope for the automatic switchover is NCE manager scenario and NCE fan. And for the third party side one, we support NCE manager controller analyzer scenario and NCE manager scenario. So so now here is just get into details for the three type of switchover. The first one is manual switchover. So for the manual switchover, let's take a look at the GIF here. So let's wait for it. The primary side is sending data through the data replication link to the secondary side, and switch over. When switch over, this one is active, this one is standby, and this one starts to send data to the standby one. The heartbeat link is always on. For the manual switch over, when the disaster happens, an engineer is gonna go onto the DR management system and do the switchover. If the primary side is faulty, causing some keynotes to be damaged and unable to provide corresponding services, for example, a database node, a corruption, platform service node, a corruption, the common service node, and a management domain service node corruption, the NMS node, or a control domain service node, the controller or T controller corruption. These should trigger the switchover. And next one is the automatic switchover. Here's a lot of contents, but we'll be just focusing on the switch logic, here. So basically, we can see the if else switch logic. So if the DR heartbeat and the DR manager heartbeat is normal, then we're not gonna do the switchover, which is disable the DR switchover. Else, if the heartbeat is not good, the status of the peer side cannot be determined, so remain the local side as active. So let's say, so yeah, so for here I'll be explaining like why the dual active is going to happen. So we have one side, right? We have primary side, we have secondary side, and there's a heartbeat link that links to it, and the data replication link, but I'm not going to do it. So for the heartbeat, if the heartbeat link is down, there's no heartbeat, and there's no heartbeat anymore. So if we stand on the primary side's point of view, we see that I'm still working, so I'll stay active. I'm still working, I'll stay active. The link is down, but that's not affecting me because I'm the primary side. I provide services. I'm not gonna be down. And for the secondary side, the heartbeat link is down, and it says, wow, the heartbeat link is down, so probably there's some problem there's some problem at the primary side. So I'll be active right now. I'll come into use. So now we have dual active. For dual active side, a lot of like mess is gonna happen. So we don't want dual active side. Like even both standby is better than dual active for the services. And for the standby side, yeah, we can see if both are normal, we're not gonna do the switch over, else consider the status of the peer side faulty and switch to active. So it's like very easy for standby side to go active, and the active and at the same time the original active side may not be down. So this is gonna create a lot of like mess and corruption. So after we introduce the third-party arbitration, we have a brand new logic right here. Let's focus on this part. We have a new logic because now we have arbitration that connects the triangle between the two sides. Connects the triangle between the two sides. So let's see the logic. For the active side, if all heartbeat links are normal, oh, so this one is also called a heartbeat links. So let's call the other one, this as the original heartbeat, and now we have another heartbeat. So we have like two heartbeats. If all the heartbeat link is normal, not gonna switch. Else, if the DR manager heartbeat is normal, not gonna switch. Else, if the auxiliary arbitration is normal, not gonna switch and report an alarm of the heartbeat exception. So we're only gonna report the alarm and not gonna switch. Else, if the active side is disconnected from the auxiliary arbitration, determine the local side is isolated and switch the side to standby. So if this one is completely isolated, so this is cut, this is cut, this is cut, all three links cannot connect to the primary side, then this primary side is gonna go down to standby. So remember at the previous scenario, there's no way for the primary side to go down to standby unless there's like actual disaster. But for this one, as soon as it detects itself as isolated, it's gonna go standby. And for the original standby side, if all heartbeat link is normal, not gonna do anything. Else, if the DR manager heartbeat is normal, not gonna do switchover. And else, if the auxiliary arbitration is normal, we're still not gonna switch and report the alarm of the heartbeat exception. Else, if the active side is disconnected from the auxiliary arbitration, determine that the active side is down and trigger standby to become active side. So now this one is gonna turn active. Yeah, so you see how we prevent the dual active case. And for DR specification, let's use NTP configuration requirements as an example. So NTP configuration solution for DR system without a third-party side looks like this. The recommended way to do this is configure multiple external clock sources and use the external NTP clock source based on the Linux operating system. So two external source is recommended. And if you can do it, the secondary choice is to have one external clock source. And the next choice, the third choice, is to provide the NTP clock source from the active side to the standby side. But let's just focus on the recommended way. So basically, the number here are the configuration priority. So here we configure by the number one. This clock source gives time information to both primary and secondary side, and this one, and the primary and secondary side gives their information to their server, their virtualization platform, and their service node, their server, virtualization platform, and service node. And then the second priority is number two, and number three. Yeah. So this one, so the next one is when we introduce the third party side. So we can see it's like pretty easy to see. The only difference is here. All other are the same, and the only difference is add a third party arbitration side. And for after adding the third party arbitration side, we see that the clock source, the clock source one still gives the time information to the primary side, and then the primary the management node give the information to the arbitration side. Same thing for the secondary side. Also, the clock source give information to the management node, and management node give information to the third party side. This is how the NTP configuration works. And our last part, and we have seen before, different nodes needs to be connected to different network plane so that the DR system can work, is able to work. So we look here, we have heartbeat link and data replication link. For the no arbitration scenario, we only have two sides. So for data replication link, the network plane for DR network reuses the internal communication network or northbound network, or use an independent network. And the heartbeat link is on the same network plane as the data replication link. So for IP address configuration, when NCE is installed on a replication IP address is configured for each node by default. And after NCE is installed, for the heartbeat link on the management plane, manually set the heartbeat IP address of the management node. We see here, these two are the same, so I'll be just looking down here. The OMP and VRM are on the management network. They need to connect to the same network, right here. And let's see here, the OMP, the common service analyzer, and NMS and needs to be on the northbound network, which is the client network. And for southbound network, analyzer, NMS, and controller needs to connect to the southbound network that connects the devices. And for the inter-node communication network, the DR network, here are the yellow ones are the ones that need to connect to the same plane in order to send the data, to do the synchronization and the quick switchover. So for third party side, the difference here, connect the third party side arbitration node to the DR network, So for arbitration side communication link, this one, the purple one, is the arbitration link. This is our triangle here. The network plane, it reuse the internode communication network or northbound network to use an independent network. And when installing the arbitration service, manually set the inter-node communication IP address of the arbitration node of the common service node. Yeah, so this is how you connect. For more detailed information, you can go to Huawei.support to get more detailed information, like how you connect nodes to the plane, how you do how you set up your DR system and everything. Yeah, so that's basically it for today's introduction to to the disaster recovery system on NCE-IP. Do you guys have any questions? I'll be answering the questions for now. Let's answer the questions first. Oh.
Yeah. Now, if you have any questions, please leave them in the chat box. Our presenter will answer them.
Okay, let's see. So I see a question here. When NCE is upgraded from single server mode to DR mode, can the existing single server NCE system directly provide the entry for deploying the DR service? There's no direct way to provide to deploy the DR service, but you can use the single site system to DR system change guide to help you do this. I'll be typing this in the chat box. You can use this guide to help. It's called a single site system to DR system change guide. Find this on Huawei support. Yeah. And what to do if NCE failed to create the DR? So before we create and set up the DR system, we're gonna use the management plane to do the checks and detect the problem before we set up and brought up the DR system. What is the takeaway from this comparison depending on the usage and requirements? You mean this comparison? Is that the function comparison you're asking? The biggest takeaway is which is better? Definitely this one is better because before you need the entire system to be down. You need the entire site to be down in order to trigger the switchover. So like let's say, what if there's like very important micro part is down and your entire thing is still, the other things are still running, but this part is down and you're not switching over. So it's gonna create like a lot of problems for the services. But like right now, the trigger mechanism is smaller. The trigger mechanism is smaller for multiple important small services. If it's down, it's gonna trigger the entire site to switch over. And what is the deployment solutions requirements to construct a DR system? So okay, so ways to set up let me see. I'll put it in the chat box. Please see the chat box. Ways to set up the DR system. Look here, the support.huawei.com. I put the documentation down here. And the requirements, you have also asked the requirements. I'll be showing the requirements to set up the DR system is here, is this document. Yeah, take a look at these two documents. See if you can find find answers for setting up and the requirements that you need. But if you cannot access ask the Huawei engineer that you can get in contact with. Some are if it's -C, if the documentation is end with -C, then it's accessible to the public, to customers. If it's -A, I believe -A I believe is accessible for Huawei engineers, and you can find a Huawei engineer that that will help you to get the documentations. So the deployment stages. Oh, I see Pakistan Mohsin asking the deployment stages. So the deployment stages. Oh, this time we only introduce basics and some basics and an introduction. So if you want deployment or stages, or like how to build the DR system, we may add a session, and please keep an eye on our webinar. We can actually add this one, because this one is only for basics. Like we're introducing the primary and secondary side and the two links, and the third party side is the main takeaway for today's session. And for the stages and deployment, we can get into details for it at next session. And I see Farina Pack asking algorithm name. The algorithm name for, oh, here. Algorithm name is for, I guess you're asking the NTP, right? This one, the specifications, is the NTP algorithm. So NTP is called network time protocol. It's a kind of it's a protocol that the NCE requires you to configure in order to have your all the devices and sites have the same time, have the standard time. Yeah, it's a kind of protocol. Yeah, NTP is a protocol. Which algorithm is used to implement QoS policy in an NCE? And why is Linux OS recommended for? Oh, these are a lot of questions right here. I guess our time is gonna be up. Yeah, I see you guys are very active for today's session. Our time is gonna be up, so probably go to our community link. We'll send a link for today's session, and put down your questions, and our engineers, SREs are gonna service engineers are gonna get service engineers, and documentation engineers are gonna get back to you. Put down your questions in.
Yeah, you can check the box. Okay, we will put our community post link, and you can leave your questions under the community post. Okay, our lecturer will answer you later.
Yeah, we'll have a second session if people is interested.
Yeah, we are interested.
So yeah, so that's it for oh, I also have some questions to ask you guys, to check if you guys are if you guys know the DR system better after today's session. So do you guys know how many DR solutions are available for iMaster NCE-IP? Let's quickly go through these questions. I have like 5 like very easy questions to help you to like review today's session. How many DR solutions are available for iMaster NCE? The answer, does anyone know? 2? Does anyone, how many? It's actually, yeah, it's like 2 or 3. 2 or 3. So it's manual switchover, automatic switchover without arbitration, and automatic switchover with third-party arbitration. So it's actually 3, but you can say that is manual and automatic, but remember, like, one automatic creates the dual active problem, so it's basically 3. So remember, it's 3. Oh, and how many equipment rooms are required in the automatic switchover with third-party arbitration solution? Yeah, everyone know this. It's 3. 3. So you need to have a primary side, a secondary side, and an arbitration side above. Yeah. See, everybody's getting more knowledge on DR systems. So if your company needs disaster recovery, now you know. Now you know better on this topic. And which of the DR solutions may cause the dual active problems? Which one? We say there's manual, automatic without arbitration, and automatic switchover with arbitration. Which one? That's gonna cause the dual active problem. Remember, dual active problem is the largest problem for disaster recovery. Yeah. No. Which one is gonna cause the dual active? Yeah, the automatic. The automatic makes the response time more prompt, but it creates the dual active problem. That's why we need 3 sites. We need 3 sites. If we only have 2, we're gonna have problem. Okay. And where can I check? Probably some of you are interested in this problem. Where can I check the running status of the remote DR system? So I'll be just answering this. You can take a look at here. This is telling you where to log in. You can log in from this site. Where to log in, and on the management plane, choose HA, remote HA system, manage remote DR system from the main menu. So on the management plane of the primary or secondary site, you can view the heartbeat status. The data replication status, and product DR status, and site health status, and product health status of the site. So this helps you learn the system running status in a timely manner. Go onto the management plane. So the answer is management plane. Management plane, and check all, and you can check all the status if you want to do like manually. And the last question, this is about a link. So today we have talked about 3 links: the heartbeat links, the data replication link, and the third-party links, right? So which link among these 3 is used to replicate data between the 2 sites? Which one? Yeah, the data wraps, right? Data. Yeah. So so thank you guys for coming to today's webinar. I hope you have takeaways. I hope you have this for the DR system. At first, we see there's a lot of like information here, but actually, if you take a closer look, the entire DR system is just 2 sites, 3 sites, and the links between them. So, right. Thanks for coming today.
Okay, now let's thank Ms. Xing for your detailed answers. If you have more questions, please leave them under the community post. Our lecturer will reply to you later. Okay, now let me share my screen.
Yeah, for today's playback and more questions answering, I see there's like very professional questions right here. Put your questions under our post, and our documentation engineers and the SRE service engineers will get back to you. with the
Yes.
links and the documents that you need. Yeah, I'll get
Okay.
give back the control to our monitor.
Okay. Now let me share my screen. Now you can see this activity post, right? Okay. Now this activity post of this webinar. After you join the online webinar, you can answer these questions. We prepare some questions here. You can answer these questions for a chance to win 600 high coins. And you can click here. Okay, you can click here or post the link in the chat box to feedback about this webinar. Click here, I'll show you. Okay, now here is a survey of this webinar, and you can answer this survey. Now we will give 10 high coins. 10 high coins here. We will give 10 high coins for each user who fills the survey after the webinar, and 50 extra high coins for each user whose suggestions is valuable. Okay, now you can see the 2 QR code. Here are 2 QR codes, and you can scan the QR code on the left side to view the playback material of this session. Scan the QR code on the right side to fill out the survey after this presentation. Okay, now that's all for today. Don't forget to come to the community post to answer the questions. Fill in the survey. High coins are waiting for you to claim. Okay, thanks for watching. Let's see you next time.
See you next time for deployment.
Yeah.
For the
Yeah,
deployment.
thank you, everybody.
Bye, guys.
Thank you, Miss Xing. Okay.
Yeah, the playback and slides will be uploaded to the link to the post on our community.
Yeah.